such kind of industries I'm providing the solutions. So thank you once again, Dr. Joshi, to giving me this opportunity and deliver this all like intellectual people here in this conference room and giving me this opportunity to deliver this seminar to you all. Thank you so much. So what my topic for today, the discussion will be like a comprehensive additive manufacturing workflow. So what we will be discussing here is, first we will be discussing basics of 3D printing. Then we will be going through the workflow. So like what is exactly how the process is followed to reach to the point where we get a finished part. So that process flow, workflow we'll understand. And later on I will show you few case studies which we have done in my company, and later on I will discuss the market scenarios currently in the additive manufacturing area. So like I hope everyone is aware about 3D printing. So is there anyone like who would like to describe a little bit about 3D printing here? Anyone would like to take an opportunity? So basically 3D printing is z-axis, in the z-axis direction we have to build the part layer by layer. So in that x and y, the bed is where the layers are created, and in the z-axis direction the height is created of the part. So basically in that material is fed into the machine, and through extrusion the material is fed out to the nozzle, and whatever feature you want you need to create is fed through STL file, stereolithographic file, which is the meshed part, and using that mesh geometry, that layer by layer geometry is created on the 3D printed bed platform. So that is what I mentioned, creating a three-dimensional z-axis emphasis object by building it layer by layer, successive layer until the entire object is printed. So here you can see in this small animation that how the printing is done. So at the bottommost layer there is a bed. This is the bed, this black area that you can see, and once you put up a glue, so sometimes there is a heated bed. So on heated bed the part, the material gets extruded, and layer by layer, one by one, like based upon the thickness of the machine. Let's say some of the machine has very fine, up to 100 microns of layer we can build. So this layer goes to the point, and this is how the part is built. This is the nozzle. The one you can see here is the nozzle, and this, the red color that you can see region, that is the filament coming through a Bowden tube. Red and white color that you can see is the Bowden tube from where the material is extruded. This is the cooling fan. This is the arm on which the nozzle can slide. Why this is needed? Because we are building it on the XY axis. So this will help to move the nozzle in the XY direction. And there is one more arm here which will help take the nozzle in the Z direction. So we will see now like what are the types of manufacturing process currently, like how the part is being manufactured. First of all is formative. What is formative? Where the tool is required, like plastic injection molding, like forging, where a die is needed to get the part manufactured. So in that there is two-piece design. There is core and cavity. The material is being pushed through a screw extruder, and then the material comes inside this core cavity, and then we get the finished part here in the right side. Then there is subtractive manufacturing. What is subtractive manufacturing? As sir mentioned earlier, using the machining methods, like conventional machining methods like milling, like drilling. So all those methods we use here to get the final finish of the part. So here there are various technologies like CNC, 6-axis machines are there which we can use to get this part. So right now how the technology is working is that 3D printed part is also being post-processed further using subtractive manufacturing. So I have manufactured the part, let's say, and I need threading. So even threading can be done through 3D printing, but with some sort of a limitation. But if I need a thread, now what? Okay, how will I 3D print this? So in subtractive manufacturing, what you need is NC code. Okay, based upon NC coding, you can develop you can get the part manufactured. So here it is STL. It is similar to NC coding. What it does is it also defines coordinates. Okay, but using the STL file, not the step file. Okay, so what is a STL file? It is basically a meshed part having meshes, okay, and having defined coordinates, and then that we feed into the slicer, and then slicer slices the part, and then we can give the settings like what material I need, what is the temperature of the part, let's say PLA. PLA temperature is around 190 to 220 degrees Celsius. ABS is much higher, 250 to around 280 degrees Celsius. So based upon material, you will define the temperatures there. You will define other requirements like if I need a brim, I need a raft, I need overdrafts and all those kind of stuff we can define in the slicer, and we can give the command in the slicer and then we can get the 3D printed part created. So STL file can be easily done using the CAD software. What you need to do, you need to select the save as option, STL, and then you need to give the number of like how fine STL file you need to create. So there are various kind of like coarse and there is fine. So in fine, the number of triangles will be more. So what will happen? The part will be more finer. The finish will be much better. So while creating the STL file, you need to take care that the more triangles you need, the more finer part you need to do it. Like you need to select more finer settings while creating the STL. So there is the various file formats: STL file, then the OBJ, ZTL, IGES, MB, Max. So that these files you can select, and then you can give the input to the slicer as I mentioned earlier. Like there are other slicers like Prusa slicer, Ultimaker, Repetier. So based upon like different, like in Markforged, there is Eiger. So they have their own slicer. It does not need to be an open source. Okay, these are some of the open source slicer which can be done on n number of machines. But there are machines such as Markforged machines which have their own slicing softwares, and they cannot take any other you cannot make it any other settings in those slicers. And it is specifically designed for the Markforged. So there are various kind of slicers. This is one of them. So next step, if we go back to the workflow, next step is the like printing. So before printing, I need to select the material. Definitely, material will be defined in computer-aided engineering. So in this material, by this material setting, it means about the temperature settings of the nozzle, which is there, while you have to do in the slicer. So how will we understand that? How, like what? First, we need to determine what is the material needs and behavior. How strong or stiff does it need to be? Let's say, for example, I talked about impeller earlier. So impeller needs to be hard enough because it is a rotating part, it is a dynamic part, so that it doesn't fail. So definitely it will be needing a material which is hard. Okay. So in this case we can use ABS. Like I talked about soda tank. So in that case it does not need to be a hard material. So we can use a PLA there. Okay, that is a soft material, and it is a food grade material as well. PLA is a food grade material, so we can use that part and we can check it. So based upon that, I like what my application is. I will have to decide and how the loads are acting on it. Based upon that, I need to decide which material I need. So what environment will your part be in? So if it is, let's say, a PLA material and the temperature is around, the part which we will be fitting is having a temperature, increase the strength of the part. To increase the strength of the part. So let's say this is not related to additive manufacturing, but this is related to designing. So let's say I thought that this, like when we tested this part, we saw that this region was failing. This was unable to take the load. So what we did, we added a stiffener here. Okay, this is kind of acting like a stiffener, which is providing the strength in this area. So this is one of the way we added a stiffener, or we increase the material in that region to improve the strength. Okay, so these are the ways that you can more smoothen, like you can add fillets and chamfers to more smoothen the stress in the part, so that you can improve the strength of the part. Okay. So
what is expecting is probably that keeping the design same, if I change my temperature, if I change my speed of deposition, how it will affect the strength? I think that is his question.
Okay.
By changing the infill density, by the way of printing,
that was things.
Right, that is as
Okay. So in the 3D printer settings you are doing. Okay. So one of the thing is like increasing the infill density. Okay, you can increase the material, and then you can do it. So in CFF, as I mentioned, in CFF you can use multiple materials. So there you can add in the layers. You can go in layers and add the material where you need to increase the strength. Like let's say carbon fiber I need to add. Okay, and if let's say for example if there is some overhang coming in, I don't have any example. Okay, let's say this part. Okay, this region. If I need to add the strength here, I will add more supports, so that when I am adding the supports in this region, it will be printed in a much more better finish. Okay, so adding the supports is one of the way also that you can increase. So just supports is not just for building the part, but also accuracy. So where there can be a conditions where you cannot avoid supports, you need to add supports. So in that case, support will add strength to the part. So these are the ways you can add.
After we are going to remove the supports, then increase the strength.
So the correlation between the support and increasing the strength is like if like for the when you are adding the support, it is definitely helping you to print the part. But you need like while printing, if let's say if there is no support, what will happen in that case? The feature will deviate from the actual what you have designed. So your part will not fit, and maybe there is a chance that it will fail as well. Okay. So if you are adding the support, that means in that region the material is getting filled and supported correctly. So after manufacturing, what you will get is a good part. So that is why it is adding to the strength of the part.
What is that? Any more questions? So we can conclude the session.
During the operating of 3D printing, layer by layer is going up in filament. Then how the process material flow is exactly it is printing or not? How we can just
Can you please elaborate what exactly you mean this?
Flow rate.
how we can justify?
Flow rate of the material while printing.
While printing.
Okay, so from the print speed, while you are doing the settings of the part in the slicer, okay, so while setting the print speed, you can define the flow rate of like how